At the outer edge of our solar system, there is a line. Beyond that line, the rules change. Rock ends. Stone ends. Everything you thought you knew about planets ends. Something else rules out here, something that shouldn't exist. You think you know Jupiter, big planet, gas giant, has some moons, has some storms. You saw the pictures in your textbook back in school. An orange ball with a spot. Simple enough, but here's what nobody tells you. Jupiter is not a planet that just got really big. Jupiter is a star that forgot how to ignite, a failed star, unfinished. And the fact that it failed, that failure is the only reason you are alive right now, watching this video. Give me 8 minutes. I'll show you something that will change the way you see our solar system forever. Look at it, even from space, even from over 370 million miles away from Earth. It's wrong. The scale is wrong. The color is wrong. Its very presence in this system is wrong. Jupiter is so large that every other planet in the solar system, Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, you could throw all of them inside Jupiter at the same time and there'd still be room left over. Not barely room, plenty of room. You could toss in a few extra Earths just for fun. Its diameter is 88,000 miles. That's 11 times wider than Earth. If Earth were the size of a grape, Jupiter would be the size of a basketball. It weighs more than all the other planets combined, times 2, and it's made of hydrogen and helium, the exact same ingredients as our sun, the exact same recipe as a star. So why didn't it become one? Before we go any deeper, if this is already blowing your mind, hit that subscribe button right now and smash that like. It genuinely helps this channel reach more people who deserve to have their minds broken by Jupiter. Okay, back to the failed star. Billions of years ago, when this solar system was still forming, still a chaotic cloud of gas, dust, and violence, Jupiter began to grow. It swallowed everything in its path. Dust, gas, rock, ice, entire protoplanetary bodies that drifted too close. It pulled matter toward itself the way a drain pulls water, and it grew and grew and grew. It wanted to ignite. Deep inside its core, pressure was building toward something catastrophic and magnificent at the same time. That same process that lights every star you've ever seen in the night sky, every tiny point of light above your head. Jupiter reached for that threshold for millions of years. And then it stopped. It didn't have enough mass. To trigger sustained nuclear fusion, the same process that powers stars, you need to be roughly 80 times more massive than Jupiter. It had only about 1,000th of the Sun's mass. It fell short by a distance that, in cosmic terms, is almost nothing. Almost. Think about that for a second. If there had been just a little more matter in that primordial nebula, if gravity had gathered just slightly more gas in one place, we would have 2 suns. Earth would orbit a binary star system, and no complex life on it would have been possible. No humans, no dinosaurs, possibly no liquid water at all. Instead, Jupiter failed, and we exist. Dark, stormy, furious giant, and still radiating more heat than it receives from the sun. Still angry about what it almost became. Jupiter is the solar system's unfinished masterpiece. Now look at what that failed ignition did to its atmosphere, because all that heat, the heat that should have become stellar fire, had nowhere to go. It's locked inside, and it creates a kind of chaos that exists nowhere else in the solar system. There is no surface, none at all. There is only atmosphere, going deeper and deeper and deeper, until the pressure transforms everything into something that shouldn't exist. But the upper layers of that atmosphere are already beyond comprehension. Clouds of ammonia whipping around the planet at 300 miles per hour. Bands of brown, gray, and cream, each individual band wider than the entire Earth. Each one a massive river of gas moving in the opposite direction from the one next to it. Imagine 2 rivers flowing side by side in opposite directions, and between them, constantly, vortices and storms and cyclones are being born. Temperature in the upper clouds, negative 234 degrees Fahrenheit, but just a few hundred miles deeper, over 53,000 degrees, hotter than the surface of the sun. And there, right there in that hell, something sits perfectly still that shouldn't. The Great Red Spot. It's been staring at us for 3 centuries straight. Staring. This isn't a storm in the way you think of a storm, not a hurricane that rolls in and passes. This is an anticyclone, a wind system spinning counterclockwise, large enough that the entire Earth fits inside it with room to spare. Winds at its edges reach 270 miles per hour. It has been churning continuously for at least 300 years, maybe 350. We don't know exactly when it formed, because it was already there when Giovanni Cassini first pointed a telescope at Jupiter in 1665. It was spinning when Bach was composing, when Napoleon was at war, when Lincoln was assassinated. It's spinning right now while you're watching this. But here's a detail scientists noticed recently, and it's unsettling. It's shrinking. Back in the 19th century, it was large enough to fit 3 Earths inside. Now, just 1. It's contracting for reasons we don't fully understand, and nobody knows whether it will stabilize or disappear entirely. A storm that has outlived a dozen human generations may be dying, and we don't even know why it was alive in the first place. And look, if your brain is doing what my brain was doing the first time I fell into this topic, if you're sitting there thinking, okay, but how does this get even weirder? It does. Way weirder. Subscribe right now, because this is exactly what we do here every week. We go so deep, there's no coming back. And what's coming next? What happens if you fall inside Jupiter? That's the part that still gives me chills. What if you fell in? What if somehow you were right now hurtling toward Jupiter? No spacecraft, no protection, just you and that atmosphere. The first few seconds, it looks peaceful. White ammonia clouds around you, soft, diffused light. You could almost convince yourself things will be fine. Then the sky goes dark. The pressure begins. Not like atmospheric pressure on Earth, not that plugged ears feeling on a plane. This is something that has decided to end you methodically. A few hundred miles down, the pressure is already dozens of times greater than on Earth's surface. The temperature has passed 1,800 degrees Fahrenheit. You're falling through a thick, superheated soup of hydrogen and helium compressing so hard it stops behaving like a gas. It becomes a liquid. And here's where something happens for which we don't even have a word in everyday language. Even deeper, at depths where the pressure exceeds Earth's by millions of times, hydrogen gets compressed so completely that it starts conducting electricity. It becomes metallic, liquid metallic hydrogen, a state of matter that doesn't exist naturally anywhere on Earth. We've only managed to create it in labs, in microscopic amounts for fractions of a second. On Jupiter, there's an ocean of it, tens of thousands of miles deep. It swirls and churns and generates a magnetic field so powerful it tears open the space around it for hundreds of millions of miles. And you would have been crushed, melted, ionized, and scattered long before you ever reach that layer. Even theoretically, we don't even know for certain what's at the very core. Possibly a rocky nucleus the size of several Earths, possibly something else entirely. The Juno probe that NASA launched in 2011, still orbiting Jupiter right now, keeps sending back data that contradicts itself. The core turned out to be fuzzy, as if it's partially dissolved into the surrounding metallic hydrogen, which, according to every model we have, shouldn't be possible. Jupiter still refuses to explain itself. Even if you stay at a safe distance, Jupiter is terrifying. If you could see its magnetic field with your eyes, not the planet, but the field itself, it would appear larger than the full moon in our night sky. Not a little larger, not twice as large. Shockingly, implausibly, almost offensively larger. It stretches 400 million miles in the direction away from the Sun, all the way to Saturn's orbit. If it glowed invisible light, we'd see it from Earth with the naked eye on every clear night. If you could hear Jupiter through a radio antenna, and spacecraft can, it screams. A literal electromagnetic scream, blasting powerful radio waves in all directions. That scream was first detected in 1955. It hasn't stopped for a single day since. Jupiter's radiation belts are roughly 10 times more intense than Earth's Van Allen belts. The Galileo probe NASA sent to study Jupiter directly was taking such massive radiation hits that its instruments started failing. Engineers had to carefully calculate every single orbit to avoid the most lethal zones. If you were standing on the surface of Europa, one of Jupiter's closest large moons, just 390,000 miles away, without full radiation shielding, you would receive a lethal dose of radiation in about 1 day. It is the most beautiful object in the outer solar system, and it would kill you without ever noticing you existed. Here's the detail most people simply don't grasp. Jupiter isn't just a planet. It's almost its own separate solar system. 95 officially confirmed moons orbit it. 95. Some are just chunks of rock. But the 4 large moons, the ones Galileo discovered back in 1610, are full-blown worlds. Io is the most volcanically active body in the entire solar system. Over 400 active volcanoes erupting simultaneously at any given moment. Jupiter's gravitational pull literally kneads it from the inside, like dough, heating its interior so intensely that the surface is constantly being rewritten by eruptions. No stable surface. It completely renews itself every few thousand years. Europa is covered in a layer of ice a few miles thick, but beneath that ice, a liquid ocean, saltwater that has existed for billions of years, with hydrothermal vents on the seafloor, with chemical reactions sufficient to support microbial life. At least theoretically. NASA is already building the Europa Clipper mission to study it up close, not because it's interesting, but because we genuinely consider it one of the most likely places to find extraterrestrial life in our solar system, right now, in our own cosmic backyard. And yet, despite all that brutality, radiation, magnetic fury, we owe Jupiter. Its gravity acts like a giant vacuum for the entire inner solar system. For billions of years, it has been pulling in asteroids and comets, objects that without its intervention would have had a direct course toward Earth. Astronomers calculate that Jupiter has absorbed or deflected thousands of potential impacts over the entire history of the solar system. It has been taking bullets for us, repeatedly, silently, with zero acknowledgement from our side, until the moment we learned to build telescopes. In 1994, comet Shoemaker-Levy 9 slammed into Jupiter. Didn't just graze it, slammed, breaking apart into 21 fragments, each one leaving a scar in the atmosphere, larger than Earth. One of the impacts released energy roughly equivalent to 600 times all the nuclear warheads on Earth simultaneously. Jupiter didn't even flinch. But, and here's where it gets complicated, gravity is a double-edged weapon. The same simulations that show Jupiter as our protector also show Jupiter, under certain conditions, hurling objects toward the inner solar system, changing trajectories, turning a harmless orbit into a collision course aimed directly at Earth. Some researchers believe that without Jupiter, we'd have had fewer major impact events. Others believe far more. The debate is still open. The king protects, and the king can destroy. The same force, the same planet, the same math, just pointed in a different direction. Jupiter stands at the edge of the outer solar system like a gatekeeper that absolutely does not care whether you survive. A failed star, an eternal storm, a magnetic monster, the jailer of volcanic moons, and the possible guardian of under-ice oceans, an unfinished masterpiece. And maybe that's the point. Maybe the most remarkable things in the universe are not the ones that became what they were reaching for, but the ones that stop just short, that carry within them the energy of what they almost were, that swirl and rage and radiate because of what they aimed for and never reached. Jupiter reminds us that the universe was not built for us. We are small guests, temporary travelers, living in the shadow of giants who don't even know we exist. Now, drop one comment. What do you want to watch next? Saturn and its disappearing rings, the black hole at the center of our galaxy, or the death of the sun? And what happens to Earth? Write it below. We're going there together.